Hello everybody, my name is CraigBennettII, and today I'm going to make a Dummies guide for Quantum Entanglement Internet. And this is something that the real tech professionals have to keep up with and know. Just a little jab to another channel, inside joke for those of you who watch it. But as far as that goes, I was informed that my Quantum Entanglement video was a little bit too advanced for some people and they couldn't really keep up. So I figured I might as well just make a Dummies guide just to give you the nuts and bolts of what you need to know. So as far as what you need to know, first things first is there's going to be no wires between you and an ISP, internet service provider. Second is we don't know why most of this works. Third is it's very, very hard to make this, so it's going to be deep in the future when this stuff comes out and commercially available. I think 2030. So as far as that goes, oh, by the way, I got links down below to the previous video, which I talked about, plus a wiki link talking about quantum entanglement. I'm talking about more so on the networking side, communication side, than anything else, because this is what you came here for. So as far as that goes, the quantum entanglement, what that basically means is, in a nutshell, you got two particles that do the opposite stuff. It's very predictable. So let's just keep things easy. One particle, if it's facing up, the other particle is facing down. Just keep things easy. Now, as far as things goes, some scientists in the past, way in the past, said, well, it's not possible to use this in communication. It's actually been proven to be you can use this in communication. See, what happens here is you need to actually have it where the communication, the reading is in the same direction, and one of the particles you're manipulating, the other particles for listening. So how this would work is for every particle you have, like say for example on your home side, for every particle that is sending out information is another particle listening, and same thing on the ISP side for your stuff. Now, as far as things goes, these particles are very difficult to make, and you basically have to make them into existence type of thing. It's very, very difficult to make at this time, and that's the reason why you don't see it in most households. But they're synced. No other particles should be, screwed with. Basically, if these two particles, like I say, my hands are two particles. If these two particles are doing something and they're synced, no other particles in the world should be interfering with them too, and they shouldn't get any interference from them. In theory, and I'll explain a little bit more on that in a second. So what happens here is, since you got one particle for sending and another one for listening, what happens here is now you got ones and zeros, and then on top of that you got a simultaneous. As it's sending a signal out, you can listen to it. So now you have communication. You have communication where it can send signal out and listen. So you got in bits, ones and zeros, and basically you just need to add this up into the petabyte area. So that's something that you got to keep in mind. Once you got enough of these, you got petabytes. You get into the petabyte area. So you go into the petabyte internets. You might hear, oh, I get like 20 megabytes or something like that. Well, how about a petabyte? That's you can download. We're talking about speeds where you can download the entire iTunes library in like a couple minutes. That's the speeds we're talking about. Realistically, it's probably not going to get into that until much later. You're probably going to see the same speeds as you are now, or a little bit better. I imagine you could probably get into the gigabytes to make it marketable. Petabytes is much further down the road, but once you get into that, I imagine it will start taking off like crazy, and to the point that it's like, why are we increasing speed type of thing. So as far as that goes, that's something to note. Now, as far as distance, this is where the no wires come into play. What's been found is if you have one particle in Japan and the other one in the United States, works just as fine. It's instantaneous, by the way. There's no lag at all. It's instantaneous. So you can have one in Japan, one in the United States, works just fine. You can have one in whatever part of the world, and they're in another part of the world, just works fine. Theoretically, it should work across the entire universe. Theoretically. What's in reality is we don't know. What we, and when I say we, humanity, scientific area, whatever, what we're hoping for is that we can use this for space communication. So for something like, oh, you got someone on Mars, instead of having like a couple minute delay because you got send signal there, and then you got to listen to signal, and same thing with them. They got, once they send signal, they got to wait to hear something back. Well, here's the thing. That will be gone. It'll be all instantaneous, because it's instantaneous change. Because, okay, if this one is facing up, then that means the other one's facing down. So you know, okay, is that one sending 1 or a 0? So what happens here is it's instantaneous communication, and if it works with no distance, right now we know it pretty much works anywhere in the world, which is cool. Then that means that we can communicate with something like a spacecraft instead of waiting like a couple hours, because you know, the spacecraft goes so far, you got to wait half an hour for it to get there, half an hour for it to get back, for the signal. And this will eliminate all that. You can see things real time, control things, and correct things in real time. Oh, we didn't get that shot of shattering that correctly. Let's go take a few more of them, so you get all that real time as if you were there. So it's pretty cool stuff. Now, here's where the thing, you as an individual, where that comes in. You might be saying, oh, well, then that means that in the future I will need to have a laptop that's connected to the ISP, Internet Service Provider. That's not the case. Your laptops, your mobile, your phones are going to be one thing. Let's just throw them out the door real quick. Your laptops, your desktops, your TVs, your cars, and a few other things, they are going to be the same as they are now. Cars may be linked up, depends on the car and the systems and whatever. Like if it's like an OnStar system where it's made purely for that company, I can see where that would be put in place. But if it's like, you know, like I say, for example, you bought a XYZ car and that has online features, that's probably going to be the same as it is now. But as far as, or at least what the mobile phone will be like, but as far as the laptops and everything else goes, that's what it's going to be like now. The part that's going to change on your house is the modem. See, what's going to end up happening is the ISP, the Internet Service Provider, they're going to end up having one set of particles that will match up with your modem, and what would end up happening is your modem will just communicate with that straight through, and all signals coming out of the ISP, Internet Service Provider, will be using that type of stuff. They'll just have, for each house, they would have a set of particles that are synchronized. Because keep in mind, the particles have to be synchronized. And with this, we don't, as humanity, we don't know of a way to desynchronize and resynchronize particles. In fact, getting the particles synchronized between each other, that has to happen on creation type of stuff. That there's I don't want to get too deep into it because of the length of the video, and I don't cover that heavy into scientific stuff on that aspect. But the thing to note is basically the particles, like for your modem, that will be synced up to something at your ISP. And let's say, for example, you stop being a customer, you can send back your modem and they'll just give it to someone else. So, you know, that's that. Oh, your modem went crap. Now they got to change the part at their end. So that's something they got to keep in mind. I think what's going to end up happening is all you're going to see on your end, oh, we need you to change out your modem to this new fancy modem, and you got to buy it through us. And be like, oh, why? I bought my own modem, or it's better. And you say, oh, they'll be telling you about quantum entanglement and trying to keep it easy as possible by using marketing terms and whatever it may be. But in reality is, if you use another modem, it ain't going to work. So what you do is you either rent or buy out the modem, however they want to terminology is. And whenever you stop being a customer to them, you give them back the modem. Simple as that. I think what's going to happen is probably a rent, realistically, and they'll send you the modem, and that's that. So here's the kicker, though. What happens if your laptop's a company laptop? One thing that could happen if this gets small enough, as far as the quantum entanglement parts get small enough, the IT department, and this is where the technology professionals have to actually pay attention to, is they can put something on the actual laptop itself. And what would end up happening is, instead of using a VPN, where what happens now is your laptop, it connects to the internet through an internet service provider, and from that it connects to the company's system by VPN, and now you're into the company's system, and if you want to from there search out anything on the internet, you have to go to the internet, to their servers, which goes out to the internet again, and then the reverse of that's getting information to you. So instead of all that junk, with quantum entanglement, you would just connect directly to the servers anywhere in the world, as if you're there. Now, as far as security wise, right now we don't know. What's thought of is this to be very secure, but I'm going to tell you, I don't know. Until we know how this stuff communicates, I can't guarantee you that it can't be tapped. It's very possible that it can't be tapped, because we won't ever know. So security and was it obscurity, whatever maybe, but basically security by just not knowing, or people not knowing something, that's possible. But until we actually know how it works on the detailed level, I can't guarantee you that this is going to be the most secure thing in the world. I can say that until people know about it, as far as know how to tap into the lines and stuff, or at least know how this works on a much fundamental level, as far as how these things talk to each other, and we're not talking about theories or anything, but actually know how it works. Once that happens, I can say that may or may not be secure, but before then, it's pretty secure. Since no one knows how it works, no one knows how to tap into it, therefore it's secure. So with that in mind, that's something to keep in mind right there. It's very difficult to say how this technology will take off in the future. What would cause this to be dead in the water, and what would you need to know about this? What would cause it to be dead in the water is one of a few things. One is simply if the having so many entangled particles in such tight proximity, but like having one on one side of the world and the other on the other side of the world type of thing, that might cause interference. Like it doing something to us, to any living matter, whatever it may be, it's not really going to be a worry at all, because we would already have side effects, because guess what? Happens naturally in space. But the fact of the matter is since we don't know how they communicate, there's no way of knowing if there's kind of like a jammer. If you don't know what a jammer does, it basically amplifies the signal. Like it sends the signal out. It's like a crowd of people talking. When you're just trying to talk to the person next to you, you can't hear because all the people around you are talking at the same time, and they're very, very loud. Well, the thing is we don't know if that would happen like that, or if everything will work just fine. That part would have to be tested, and that can't be tested until there. And this is the other thing that can kill it in the water. Right now, I was told, I don't know if this is accurate number for today, but I was told it takes 1 out of a million tries to get a single entangled particle. It just takes too much energy and too much to put into it. So the fact of the matter is that could kill it if we cannot find an easier way to make them. And it looks like we are finding easier ways, but if we just hit a peak, it's like, oh, 1 out of every 500,000 or something like that. It's nowhere near good enough. So unless we find a very easy way and an affordable way to do it, it's gonna be dead in the water. There's just no doubt in my mind about it. So as far as that goes, that's pretty much about it. If you want to know more about it, I'll leave a link down below to the longer video. I'd note that I talk about like white boxes and stuff like that in that video, which gets into more things that would happen because of this. But as far as that goes, if you got any questions, anything else, then feel free to let me know. If you got more information on this, then feel free to let me know. Again, there's just too many unknowns to give you 100% fact on when it's going to come out. It's expected to be about 2030. It could be a lot later. Also on how exactly things work on a like how it communicates in real time type of stuff. That's something that I can't answer, nor anyone else in the world can answer. There's a lot of theories out there if you want some, but actual facts, I don't think anyone can give you that at the time. And it really doesn't matter. It's just, for me, I just care if it works. But anyways, I'll see you next video. Hope you have a great day.